Welcome to a MyNote series videos. So in this video I am going to be helping you to define what is relative atomic mass. We'll also look at what is the mole concept. We'll also look at molar mass, and finally we will look at relative molecular mass and relative formula mass. So I'm going to tell this in a way like a story. But what is important is to take the factual information from this story. So the first point that we need to look at is, of course, relative atomic mass. So what is relative atomic mass? Well, when scientists have actually realized that atoms are very small particles, what then they were then focused on was to actually find out how much they weigh. So they were more concerned about the quantity, because when one is performing a reaction, they should also be aware of how much to expect when the reaction is done. So when they have been concerned about quantity, which is another word for size or amount, so what then scientists did was they came up with a system. So they took an atom which was carbon 12, and they said that this carbon 12 has a mass of 12 atomic mass units. So this AMU stands for atomic mass units. So when they have decided this, it is also important and crucial to note that carbon has 6 protons and 6 neutrons. Now, if you look at this, 6 plus 6 gives you 12. And remember, when you are learning about the atom, it was specified that the mass of the atom is concentrated at the nucleus, and the protons and the neutrons are the particle inside the nucleus. So now, when scientists have came up with this system, they then measured every other mass of the elements in terms or in relation to the mass of carbon 12. So as a result, all the other elements like hydrogen, iron, nitrogen, oxygen are measured in relation or relative to the mass of carbon 12. Hence, we have relative atomic mass. So now, when they have done that, then they realize that, well, as much as this might work out, but this is not practical. So they were looking for a way to try and change this atomic mass unit into a unit which is more practical whenever we are doing experiments in a laboratory. So then they asked themselves the question, how much or how many atoms will it take for us to have 12 grams of carbon 12? So they asked the question, how many atoms of carbon 12 will we need in order to have 12 grams? And it turned out that they needed 6,02 times 10 to the 23 atoms. And the scientist who actually discovered this was a scientist by the name of Avogadro. So this number is then referred to him as the Avogadro's number. So it is named after the scientist who actually came up with this system, which is the mole. So they call this 1 mole. So they said, if we have 6,02 times 10 to the power 23 atoms or particles, then we have 1 mole of that substance. So for carbon, it actually matched very well. However, what was even more interesting is that when they took other elements in the periodic table, like say for instance aluminium, which is Al, it's actually also matched when you do it with nitrogen, which has a mass of 14. It's also matched if you take oxygen, which has a mass of 16 atomic mass units. When you take 1 mole of that, you'll get 16 grams. So then they came up with the mole. So then a mole is defined as 6,02 times 10 to the 23 atoms of a specific substance, or that particular substance. So when we have discussed the mole and the relative atomic mass, then the mole gave scientists another way of looking at things. So they have realized that each mole for a particular substance has a distinct mass rather. So in other words, it has a different mass. So for carbon it is 12, but for hydrogen it is 1. So then they said the mass of 1 mole of a substance, they then called it the molar mass of that substance. Excuse my writing. So they called it the molar mass of that particular substance. So now they had the molar mass, they had the mole, and they had the relative atomic mass. Now the only thing that was left actually was now the relative molecular mass and the relative formula mass. Now this is actually an easier concept now that we have spoke of relative atomic mass. So if for instance you have carbon dioxide. Carbon dioxide is made of carbon and 2 atoms of oxygen. So everything is measured in relation to carbon 12. So in order to find the molar mass of CO2, we will then take the mass of carbon, which from your periodic table would be 12. And then you're gonna add it to 2 because you have 2 oxygen atoms. These 2 here. And then how much does an oxygen atom weigh? It weighs 16. Now if you add this, you'll get 44. And the unit for molar mass is grams per mole. So this now, when you're speaking of the units for the molar mass, then it actually brings us to another thing, which is N, which is the mole or the number of moles, has the units of moles. So, and then obviously the mass has the units of G or grams. So now I hope that in this video it was actually clear how these few concepts relate. The concept of the relative atomic mass, the mole, the molar mass, and the relative molecular and relative atomic mass. Thank you for watching the video. Please subscribe to my YouTube channel for more videos.